Our most enjoyable part of this week was the rocket launch. From this experience, we grew as a team and developed better ways of cooperating with one another. Collaborating is a skill we all agree is important, not only in working for NASA, but in any professional field.
Out of this week, we reflected a lot off our mentor and intern. They were so fun to talk to and knew so much in their field. At the end of the experience, they didn't only become our role models, but our best friends. One experience we reflect on is when we were building our rockets.
Important lesson we learned from this week was the ability to collaborate. In a team with 11 people, it's really easy to keep to yourself. However, making something truly great from the ground up requires input and assistance from all spectrums. This will guide us to be more effective in working with our colleagues.
Our team presented the discovery phase of Mars. Essentially, this is where we will go once we land. Who are we? What can we be? Where are we going? What's out there? What are the possibilities? These are all the areas of depth we covered in the presentation.
Our 3D tool was inspired by a simple question. If you had a tool to fix a ventilation machine on Mars, what would it look like? We went through many steps from talking to sketching to designing and brainstorming. The finished product was a combination of ideas. The wedged end is for prying ventilation items. The two hexagonal proprietary screw casts are for easy access to screws, while the other end is a simplified wrench. This tool is effective to the survival on Mars and easy service on ventilation units.
Saturn V at Rocket Park with chemical engineer Norman Chafee was definitely a highlight of the experience. Rocket Park was marvelous along with the Saturn V, and being one of the first rockets to take mankind to the moon, it continues to amaze humanity with its design and history.
At Apollo Night, we saw the Mission Control Centers and learned from Frank Hughes about the Apollo program. It was interesting learning the mindset back then and taking a step into the shoes of the pilots and mission specialists.
The lander was composed from the idea that survival is vital. Therefore, we have created many techniques to make sure that it lands as safely as physically possible. Our lander must have an impact velocity of 3.5 meters per second, and the parachute must be designed so it can slow the impact velocity.
When we're inside of the space vehicle mock-up facility, we met up with CJ Kanalakos to talk about robonauts and the potential future of space life. We got to see many prototypes of future technology used in space.
At the Space Vehicle Mock-up Facility in Building 9, we got to see so many of the vehicles and areas of robotics in the making, from private companies like SpaceX all the way to Boeing. They are all collaborating with NASA.
Special thanks to our supporters, the state of Texas, the Houston Rodeo, our NASA, and the U of H system.
Thank you!